UK National Quantum Technology Hub in Sensors and Metrology, led by Birmingham in partnership with the Universities of Glasgow, Nottingham, Sussex, Strathclyde and Southampton, is aiming at developing sensors and metrology based on essentially atomic systems, cold atoms, thermal atoms and ions, and starting from existing laboratory-based demonstrations of being better than any classical technology and get these into applications. Solve the engineering problems, but at the same time build the market and talk to end users so that we do it, as I learned here at Industrial Park, the nice keyword, purposeful innovation. And that is really the key, to make it purposeful, this translation from fundamental science into technology. We are looking at sensors in the direction of rotation, gravity, time, electromagnetic fields and magnetic fields. And so for these, we see early adopters in the field of gravitation to have a look into the ground, and we are already working with the civil engineers to detect the pipes and the sinkholes, which currently cause a lot of trouble in the roads in terms of road work, digging or houses or dangers in the ground. But we are also very keen on the clock developments, where we're working very closely with the National Physics Laboratory to get a range of different type of sensitivity clocks out into the market. And we are very keen to be here at Industrial Park to learn about the potential applications in the communications area, where it's about synchronizing future broadband networks, possibly energy networks. Smart energy will require precise timing to keep energy synchronized, but also to have all the intelligent sensors at the different places communicate with each other. And part of that might be also a question of having resilience towards GPS failures, which are currently delivering timing signals to the networks. This work is mainly done by NPL, but we are very keen. Of course, we see the market in the financial trade sector, so by having very precise timestamps for financial transactions to know in high-speed trading who has put in which bit first, to be able to essentially reconstruct failures like the very short crash which happened a few years ago, which was just done by computer trading. So to be able to know what exactly happened there, you need the timestamps and absolute precise timestamps. We are very keen to get clocks into these applications, but that will require more discussions with end users, and so that's why we're here for. We want to know these applications, what parameters will be needed to be able to point our directions, our developments in the right direction. We are very pleased with the industry engagement. The Quantum Technology Initiative has really got the industry interest up. So they are talking suddenly to physicists, which they usually wouldn't do in terms of development and research. But it really has helped a lot in getting interest, in getting communications going, as we have over 70 industrial partners in our hub. Most of them are end users who are interested to be briefed on the potential final uses, disruptive uses of the quantum technology. We get them to think about the potential disruptive opportunities in the markets to help them grow their business in the future, while they give us the triggers to know what kind of parameter ranges do we have to look at when we are working on doing our prototypes. The component industry is the other very important industry links we are working with. And so we have some very strong partners like E2V, M2, who are already part of our hub and helping to develop laser systems and very robust and small vacuum systems. And we are growing this space and are very open to knowledge transfer. We are setting up a technology transfer center where you can transfer the knowledge in building these sensors, but also in using them to these companies. The space, of course, is another very interesting area of development for the quantum technology. There are at least 4 space missions in discussion between scientists, 3 of them in fundamental science about testing general relativity via equivalence principle tests or gravitational wave detection using cold atom-based quantum sensors, but also putting up a clock into space. A master ultra-precise clock will be necessary in some years as we see the clock development development, moving towards precisions of 1 in 10 to the 18 or better. 1 in 10 to the 18 has to be compared to the Earth's tides, which actually give you a shift of 30 times that. So you start to have correct for gravitational effects very precisely. If you would keep clocks on ground, at some point they have to be moving up into space and possibly also nurture our next generation satellite navigation systems. At the same time, we are partnering a group to do the next generation gravity missions from space to get a map of the whole Earth about water levels, climate research via gravity, via the gravitational profile of course, where rain falls down, it will be a bit denser, you'll see more gravity from these regions, and you can get a very accurate model of the entire Earth by looking from space at the gravity fields. The HUB initiative is highly significant in terms of providing an anchor point for industry to come to have a focal point where we can get all the interested parties coming together and then distribute out again to the scientists on the ground doing the work. So it makes the whole interactions much more transparent. The other thing is that it gives enough momentum to really have all the components we need for the technology development. We can help the component technology developments by doing different components such as integrated laser systems in the Glasgow Nanofabrication Center, doing self-contained vacuum chambers with E2V in their facilities in Chelmsford, doing micro-optical delivery systems in Southampton. All that can then be brought into a system engineering approach in the Tech Transfer Center and then again interfaced with industry. And the role of the HUB in that is quite interesting because we are starting from a point where all the knowledge sits in academia, and so you have to start with transferring everything out. But if we are successful, and it looks very much we are, because we got much more Innovate UK industry partners wanting to build these sensors than we were originally expecting, then this will be done, much of the production will be done in industry quite soon. And so the HUB will have to transform, be flexible in terms of how it interacts with the industry partners and moving more towards the application demonstrations in engineering, solving the engineering problems in like the civil engineering sector, in the oil and gas energy sector, under the ground, in the telecom sector. So it will move more towards engineering, but at the same time establish and keep a fundamental science essentially knowledge escalator chain into the production, into industry. So create something which is lasting and sustainable transfer between academia and industry.